Some fires start from faulty wiring, such as a frayed lamp cord. The bare wire...
Well, let that be a lesson to you. Always check your electrical connections before you just stand and stare out a window.
The boy knows how to use it. How does this liquid put the fire out?
Before I get to explaining how a fire extinguisher works, we first have to understand what it does. And what it does is it extinguishes or puts out fires. But what causes a fire in the first place? That is, what conditions are necessary to produce a fire? Now, in chemistry, we refer to reactions that produce enough heat to produce a flame as a combustion reaction. Now, a combustion reaction requires a few things to happen. It requires, one, that we have some sort of fuel, and that fuel could be old newspapers, twigs or branches, or even gasoline. We also require oxygen, and most of the time that oxygen comes from the oxygen surrounding us in the air. And we also need some sort of ignition to get the temperature high enough for the reaction to occur, and that could be in the form of a flame from a match or a spark. Now let's take a closer look at what actually goes on during a combustion reaction, so that will help us learn how to identify them. Well, the first thing that we need is, as I've mentioned, a fuel. And this fuel also has to be in the presence of enough oxygen gas. And typically that oxygen gas is found in the air. But what are the products of this type of reaction? Well, we also need some heat in order to get this reaction going. That is, we have to get the reaction temperature high enough to a point that we refer to as the ignition temperature for this combustion reaction to proceed. And then what it does is it produces oxides. Remember, we're talking about a fuel reacting with oxygen here, so any product that's produced from the reaction of an oxygen is going to produce oxides. Now, in the case that our fuel is, say, a very simple hydrocarbon, and just as a side note, a hydrocarbon is aptly named because it contains hydrogen and carbon. In the event that our hydrocarbon fuel is a very simple fuel called methane, and typically, if you're in a chemistry lab, that's the gas that's coming out of those taps, in the presence of oxygen and enough heat, it's going to produce oxides of carbon and hydrogen. Now, the carbon oxide is a very common one that we refer to as carbon dioxide, and the hydrogen oxide is also a very common one that we refer to as water, or dihydrogen monoxide. We refer to this as a complete combustion reaction. But there are conditions under which a complete combustion reaction may not occur in the reaction of methane and oxygen gas. Let's say we don't have a high enough heat, or there's an insufficient supply of oxygen. What can arise is something that we refer to as an incomplete combustion reaction. And there are two other products that are going to come about: carbon monoxide and carbon. And we typically associate this carbon with the soot or black material that we get out of combustion reactions with, say, a candle, or when we notice that a fire's burning, we see the black soot, and that black soot is typically that carbon material. Now that we have a better understanding of what is needed for a fire, we also have a better understanding of what we can do to control these fires. So, we can talk about our fire extinguisher. Now, the way that a fire extinguisher works is that within it is a compressed gas. And sometimes within this compressed gas, we also have some other materials as well that the gas is going to propel onto the fire. But if you think about those things that a fire needs, it needs enough heat and it needs oxygen. If we can cut off these supplies, that is, we can lower the heat or cut off the supply of oxygen, we can put out the fire. And that's the basic premise by which these fire extinguishers work. So when we pull the pin and depress the nozzle, what we are going to get is a gas that's being propelled, going from an area of high pressure inside the canister to an area of low pressure outside the canister. Now, in some cases, there is just carbon dioxide gas in here. The carbon dioxide gas, which is heavier than air, is going to go low to the floor, and it's basically going to cut off the oxygen supply. There are also instances in which there are propellants, and these propellants are going to contain in with them things like baking soda or sodium carbonates or various other compounds that, when they heat up, and baking soda will decompose at a relatively low temperature, produce carbon dioxide. And this carbon dioxide again is going to douse the flame and reduce the amount of oxygen available to it in the air, thus cutting off its supply of oxygen, removing effectively one of its reactants in the combustion reaction and preventing the combustion reaction from going any further. Now, in classic fire extinguishers that just have water, the water effectively does the same thing. It cools the temperature, lowers the temperature of that combustion reaction, and also douses the flame, removing some of the area around there that you're going to have oxygen gas coming in contact with it. And so it's sort of a twofold reaction. A lot of the things that we deal with when we take a look at fire extinguishers aim at reducing the temperature and also cutting off the supply of oxygen to the flame. And that's effectively how these types of reactions work and how fire extinguishers work to prevent them or reduce them. Now, while we're on the topic of classifying chemical reactions, such as a combustion reaction being complete or incomplete, based on the reactants and the products that we have, I want to take a look at a couple more simple chemical reactions that we can classify. And the first type kind of goes hand in hand with a combustion reaction in that things break down through its process. And that is a decomposition reaction, one in which we have a larger substance that, through the process or through its reaction, breaks down into smaller substances. And the one that I've kind of already alluded to is when we put baking soda or sodium bicarbonate onto a flame. And it decomposes once it's heat up, and we refer to this therefore as a thermal decomposition, in that sodium bicarbonate or baking soda will break down into sodium carbonate, water vapor, and carbon dioxide. And again, it's this carbon dioxide that displaces the air around it because it's much denser. It settles on top of the flame and effectively removes or smothers the fire from coming in contact with the oxygen in the air. The other type of reaction I want you to be able to identify is kind of the flip side of this. That is when two smaller substances come together to form a larger one. Since a larger substance is being synthesized, we classify this as a synthesis reaction or sometimes as a combination reaction. So effectively, when we have two smaller products combining or synthesizing a new product. And a very straightforward one that we can take a look at is when we have water and we try to carbonate it, we can get carbonic acid. And this is one of the flavor compounds, or at least one of the compounds that give us that sort of sharp flavor that we tend to associate with sodas and carbonated beverages. So, after watching this video, hopefully you have a better idea of how to distinguish between a complete and incomplete combustion reaction, as well as how we can identify, just based on the general formula, whether a reaction is a synthesis reaction or a decomposition reaction. Oh, and hopefully you have a better idea of how these things work. Remember, always know where it is in your house and how to use it. Thanks for watching. Did you like this video? Did you not like the video? Was there something that seemed like it was a little off? Well, either way, we want to hear about it. So like us or leave a comment in the section below as to things that we could change or improve. And if you want to see more videos like this, you can subscribe to our channel on YouTube or follow us on Twitter.